Good afternoon, ladies and gentlemen. We might start the first concurrent session for this afternoon. My name's Tony Taylor. I'll be chairing your sessions. We've got a change in the program this afternoon. The concurrent session is still Farmers, Big Data, Opportunity, Privacy and Implications. However, Mick Keogh, who spoke in the larger auditorium before, will play second fiddle to Dr. Brett Whelan, and we'll get Brett's speech first. Dr. Brett Whelan is an Associate Professor in Precision Agriculture in the Department of Plant and Food Sciences at the University of Sydney. Could you please welcome Brett?
Okay, Felicity, what's going on here? Thank you. Okay, thanks very much. Yeah, so we've had a few of us have been been tasked with the same topic by the looks of things here, and so I've tried to take a slightly different angle here. As I said, I'm from the Precision Ag Lab at the University of Sydney, and Mick alluded to it today, and so did Robert, that the concept of big data, well, you know, that's come from a business area, I think, and the application of it to ag, and especially to ag in Australia and to ag and cotton, I think, you know, it's not a good term, I don't believe, and I think we're really looking at this concept here, that maybe we're looking to use bigger ideas with the data that we've got and get data, new data as well, but maybe change just the ideas and the way we look at it, or making more use of data, and not getting too hung up on the big idea part of it, because again, we heard this morning, again, Mick highlighted this, that there's information that you've got or people have got, farmers have got, is very valuable, but if nobody does anything with it, if it's not used, then there is no value. There is no value in that data. And so we have to do something with it. And so the big data concept, I think, has to be enshrined in this concept. It's a concept that's been, we'll get to this in a minute, a concept that's been around for a while, that we really are, the practical goal of using data for decisions is to increase the number of correct decisions that I've got there per hectare or per season made in the whole business of crop management. So we want to bring data from a range of different sources to impact on that better decision making, better decisions, more of them over space, more of them over time. And Mick alluded to some numbers there from America, but there's been a lot of numbers coming out of Australia. The cotton numbers, there were cotton numbers coming out 15, 20 years ago about the benefit, gross margin benefits of using data that you can gather on farm to improve the way you manage cropping. It has got quantifiable benefits per hectare, but it's site specific. The whole thing is site specific, so we can't give you just a set number that you're going to save. That you're going to save or make, but it is there, that's for sure. And again, just to bring this big data or data thing back down out of outer space, we're not doing anything new. This is out of one of my younger books that I've got, but from 1731, Jethro Tull, the father of agronomy. This is the things he did. He tried to change the way farming was. Instead of broadcasting, he brought in hoeing, straight rows, and he said the things you have to check, the difference between what you used to do and what you're doing now, is these things: the cost, the quality of the crop, the certainty or the risk that you take in growing a crop, and how you leave the land at the end. And we're doing nothing different now. And the concepts of using data to make our decisions is just to keep this ticking over. We're using instruments newly invented, but we're just ticking this over. And so I'd like to bring it down back into reality, I think, a bit. So these data-driven decisions, if I like to call them that sort of thing, we're going to try and merge these maybe large data, maybe not large in the business sense, data streams, from diverse sources, and that's the new thing. So we want, you know, economics, crop information, environmental information, feeding into these models that will be adaptable over space and time, that they feed into the key decisions that you want to make in growing a crop, cotton, grains, whatever you want to do. So we want to merge those, and to do that, the components of that are going to be, will be data generation and capture, and whether it's using historical information, which we will use, with real-time new sensing data plus sensors that we use already. There's a list of them there. Economic information coming in about markets, using wireless transfer processes, and we'll get onto that in a second. There's going to be some form of warehousing, some form of storing the data. We do that to a degree at the moment, but there'll be some change in that possibly. And we'll just get to the idea again that we're going to use some sort of prescription agriculture, but it will be at a next level where we'll be offering alternatives with this data, offering alternative scenarios potentially for management. Could be variable rate application, might not be, changing farm logistics based on probabilistic assessments of what we're seeing, but it's going to have a causal relationships that we all know are important in growing crops. And that's part of big data that maybe gets lost from the commerce sense. They just go looking for correlation, and we don't want to do just that in growing plants. And so Mick touched on things that are out there at the moment, so I'm not going to spend too much time on this at all, but there are companies that are going down that pathway that I'm talking about, but there's nobody anywhere near that level of detail that I just discussed, where we want to go. Climate Pro, Mick talked about this morning, has got a range of things. The last one they've got is field scripts, which I haven't got up there. And field scripts it takes your yield data, you pump it in through an advisor into the company, they put it into a database, they look at your yields relative to the database, they give you a prescription about it's only on seed, rate and variety. They give it back out to the agronomist, goes into your farm, they collect the yield data, put it back into their data warehouse, and so they are starting to churn over individual data. A range of other companies. Aware uses weather data prediction. I won't lag on these too much, but I'm just trying to follow up with Mick that there are a lot of people coming down this pathway, but nobody's doing it in space across time like we were discussing, really. There's not really much going on. DuPont, that Encirca thing there. Raven, I've got a whole process, a slingshot process. Deere, that Mick alluded to as well here today. And this John Deere part here that I've highlighted here is something slightly different to what Mick was saying this morning. This is their actual, the telematics, the communication. And it is, I think, a very useful part of the whole process that will be able to eventually communicate this information around farm, around different places, between machines, doing things. And why is that? Well, I've got one example here. So here is engine load, recorded engine load on a tractor driving at Sowing. So it's got gear engaged in the ground, and so the engine load is changing as it's pulling through the field. What does that look like? A map of the soil. So the information that's being recorded by these machines out there, if it's used correctly, can provide you with valuable information, and that if we can save that, if we can record that, it will be very useful to you, even while you're just doing a physical task. Now, there's no numbers here about what goes on in Australia, but there's numbers that goes around in the States saying that there's basically 80% of any information that's gathered on tractors out there doesn't go anywhere, stays there, does nothing. But there is valuable information. If this telematics comes online and works well, there'll be information for free. Our tractors are pretty expensive, but relatively for free that'll be around there. So what I wanted to just briefly touch on is the processes that we think we would want. At the moment, we've got a system, I guess, and this is very generalised, I put here. The system that operates now in growing crops is we've got farm decisions and actions. We put some production operation data into it. We may store it somewhere on the farm or maybe with a consultant or something. We get a consultant, the instigated analysis, a consultant might give you some information, goes backwards, goes back to the farm decision. It's sort of a circular process, relatively linear. And what we'd like to do in terms of this more data for decisions is grab information from public databases. Weather information you've heard today. There's good soil information now out there, global soil map stuff that maps soil at 90 metres. A range of things, economic information. Bring that into the analysis at a bigger scale, so that hasn't really been used before. We might want to do some, Mick talked about this morning about national aggregation, but I don't think from a farming perspective we want that. From a farmer's perspective. We want local aggregation of information. So local aggregated data gives you information about how the region's going with varieties or yield, whatever, those sorts of things. And if that could be captured, then that goes into the analysis and that feeds back down into the data storage and that goes back to the farm decision. And so we've got a system now where we're starting to gather information from off-farm, using some of your information to be aggregated with other farmers and then brought back to the collective good, if you like. But what's happened now is we've got this cloud, if you like, that's maybe here or maybe not quite here yet. And what that's done for us is drop that together. It's pulled that together, that it's not, we don't have to go looking out to get this data from different parts. It's theoretically in the same place, the cloud, which makes that a bit easier, makes that process a bit easier. So in the end we have the operation, the production data feeding into this storage space, if you like, that's got some of our information being shared with other people, some of it not being shared, public database information, decisions being made together. So it all should feed in quite nicely. The problem is, and the issue that people keep raising, is that there's this issue, the issue of what was happening with Monsanto, maybe happening with the Monsanto Climate Corp idea, that big repository becomes a proprietary business. And people worry about this idea that there's going to be some bad use of, or nefarious use of the data. But I really don't believe that's going to be an issue here, but people do believe there may be a problem with that. So it's something to think about, but I don't think that's really going to be an issue in Australia. What is an issue is this, and I'm probably not telling you anything particularly new here, but there's the 4G, you might be able to see that on the screen. It looks much better up there than down here. There's the 4G network. So we see that these are the download speeds, 2 to 75, 2 to 50. To pull a megabyte of information, to move a megabyte of information, you need 8 megabits per second to move 1 megabyte of data. So the download speeds are fantastic, but you can't do it here. We move to the 3G, and okay, we're getting closer. We get out to where we really are is probably 0 to 3 megabits per second of download. But in terms of upload, this is where the issue is. Upload, we've got at the best places, we've only got up to 3 megabits per second. Slower, out in the blue, and the brown is considerably slower, snail pace. So we've got really slow uploads. Why is that important? Why am I bothering to tell you that? Because the weight of the data is the issue. We want to upload a huge amount of information, and Robert touched on it this morning as well. The information that we need to upload, where our speeds are the worst, or where the access is the worst, is where all this pumping into the cloud is going to have to happen, and at the moment it won't happen, certainly not everywhere. And the things that we want to download when we've got really high speeds, the prescriptions, the things that are coming back out, and the things that I was talking about at the beginning, are only very small, relatively small data. These figures are a bit rubbery, but you get the point. And so going back to that thing, the decision, the process that we think we're trying to get to, the stepwise process to bring better decisions from data, it looks something like that. And eventually, with Robert's processes, we might start to think that we bring in the real-time operation and production data and do real-time decisions by gathering information from the cloud when the communication's good enough, gathering it from the cloud with our on-farm sense data, pulling it together, and if the operation warrants using a robotic approach, we could use a robotic approach. If it warrants just using an augmentation of an agronomic decision, supplying the information in a format that's gathered from all these different areas, in a format that makes a decision or provides scenarios from agronomists or farm managers better, then that's the way we go. And that turns into a cyclical process that way. Fairly, relatively neat, but it obviously hinges on quite a lot of things. So what we're trying to do from the research side of things at the moment, through grains and cotton, is look at a tool like that I've got described there, that fits, it hopefully will be autonomously adapting with decisions based on what information's coming in, providing alternative scenarios across space and time, and it's going to involve the integration, as I say there, of all this data from maybe different domains. But we're not trying to bring every bit of data you possibly can get, as Robert said. We need still to check, still to research and work at what scales of observation we need so we don't gather too much information, and just exactly which bits of information are the crucial ones for each crop and the decision process. So we're working mainly at the beginning here, which is the crucial part anyway, I guess, but water and nitrogen interaction, to make it a bit more simple, trying not to blow the whole thing out. Just to finish, Mick touched on the idea of open data protocols, but there's also a push to have that storage space that I was talking about, that collapsing of the public, maybe the aggregated data together. There's a push to have that made public. So you'd have a public storage space, which meant it's not owned by Monsanto. People can access it, but not just proprietary storage spaces, having publicly accessible the data. So there's less of a privacy issue that we might discuss in a minute. There's less of a problem that everybody's going to get to share it, everybody's going to get to use it, everybody gets a bit of benefit or value back from it, hopefully. And again, just to finish that, just again back in history, that it's not all this new. Here is something that was published in the cotton industry back in 1995, and it's doing exactly what people are looking at doing now. Gathering information from different domains, on the go, assessing it, making real-time decisions if we can. 1995, 20 years ago. Cotton's a very innovative industry, isn't it? So I'll just finish up again. I think the important thing that we've been trying to get at when we talk to people about this sort of scale of work is that there's lots of valuable data out there. But if we don't move it, if we don't use it for the common good or personal good, then there is no value in it. Thanks. Thanks a lot.